5.3 Part 2 Notes, Factor by Grouping. In this warm-up, I want you to factor each of these binomials. Pause the video now and go ahead and factor these. Let's see how you did. Alright, so the GCF for the first binomial is 5x cubed. When you factor out the 5x cubed, what's left in parentheses is 2x minus 1. For number 2, 6x minus 3, the GCF is 3. And what's left in parentheses is 2x minus 1. Today we're going to learn how to factor some special polynomials with 4 terms. These are going to factor into 2 binomials. So when we do this, we're going to use some of the skills from last section, factoring out a GCF. And so we're going to take a look at 2 pairs within the group of 4, and this technique is called factoring by grouping. So if we look at this first polynomial, 10x to the 4th minus 5x cubed plus 6x minus 3, the first thing I notice is that it is in standard form, which is a good thing when you're factoring by grouping. So what I'm going to do is pair up the first 2 terms and the last 2 terms. For each pair, I'm going to simply factor out a GCF. So for 10x to the 4th minus 5x cubed, I'm going to factor out a 5x cubed. When I factor that out, what I'm left with inside the parentheses is 2x minus 1. I'm going to do the same thing for the second pair. If you haven't noticed already, these are the same ones that we factored in our warm-up. So we know the GCF for the second pair is 3, and what's left inside the parentheses is 2x minus 1. For factoring by grouping, this should always be the case, that this parentheses, what's in the parentheses after factoring out GCF, is the same. So then I need to rewrite this as the product of 2 binomials. So another way to write this is to take the 2 terms that are not in parentheses, the 5x cubed and the positive 3, to put those into the first group of parentheses, and then to take the 2x minus 1, which we see twice in that first step, and simplify it or bring it down into one set of parentheses for our final answer. The reason this works is because if you think about when we learned to FOIL, 5x cubed times 2x times negative 1, that's the first thing we did in the previous step. And then 3 times 2x times negative 1, that would be the second part of what we did previously. Let's look at some more examples. Alright, we're going to do the same thing here. B cubed minus b squared plus 2b minus 2. What I've done here is just factored out a b squared from the first pair, and I'm left with b minus 1. Think about what the GCF would be in the second pair. It would be positive 2, and you'd also be left with b minus 1. So when we write our final answer, b squared plus 2 times b minus 1. Let's look at example 2. It looks a little funny because it's not in standard form. So we want to rearrange it so that it is in standard form, which remember is just the exponents in descending order. So we're going to write t to the 6th minus t to the 5th plus t minus 1. Now I'm going to factor by grouping. The first pair I can factor out a t to the 5th. I'm left with t minus 1. The second pair I can factor out a 1. There is no common factor other than 1 between a t and a negative 1. So again, you want to think about, okay, if I have a 1 pulled out, what would get me back to the original? Well, the original would, right? So 1 times t minus 1. We want to rewrite our answer as the product of 2 binomials. So t to the 5th plus 1 times t minus 1. All right, I want you to try this. So now would be a good time to pause the video and try this example. Okay, let's see how you did. Here's what we would do first. I can factor an a out of the first pair, and I'm left with just c plus d. In the second pair, I can factor out a b, and I'm left with c plus d. Remember, we always want those parentheses to say the same thing, and in this case they do. So our final answer, a plus b times c plus d. All right, let's look at some more examples. In this one, there's kind of a little trick here, so I want you to pay attention, especially to this example. So we're going to factor this by grouping. It's already in standard form, so I'm going to take a GCF out of the first pair, a GCF out of the second pair, and see how that works. So the first pair, I can factor out a 7t cubed, and I'm left with 2t minus 5. In the second pair, I can factor out a negative 7t, and I'm also left with 2t minus 5. I rewrite my answer as the product of two binomials, 7t cubed minus 7t times 2t minus 5. I'm looking at that first pair of parentheses, or that first set of parentheses, and I notice that there's more to be factored. There is a greatest common factor among 7t cubed and negative 7t. What is it? It's 7t. So I'm going to pull that out, which would leave me with t squared minus 1. And then don't forget, we still have 2t minus 5. So this is now a monomial times a binomial times a binomial. Example 5. Looks like we want to subtract a trinomial from a trinomial here. So we want to go ahead and distribute that negative as if it's a negative 1. So we're going to multiply everything in the second set of parentheses by negative 1. That gives me this. 4t to the fourth plus 12t squared minus 35t. That was all in the first set of parentheses. It's good. It's fine now to drop the parentheses. And then when you distribute the negative, it's also fine to drop the parentheses. So that's negative t plus 5 minus 8t squared. Notice the sign just changed on those three terms in the second set of parentheses. Now we're just going to combine like terms. We have 4t to the fourth. When I combine my t squareds, I had a 12t squared and a negative 8t squared. That combines to a 4t squared. Negative 35t and negative 1t gives me negative 36t. And then I also have plus 5. So that's written in standard form, so that's a good answer. All right, example 6, we want to factor this one completely. So if I look at this, I want to figure out what is my GCF. It's a 12x. All right, so if I factor out a 12x, see what I'm left with. I'm left with a 6x squared minus a 3x plus 2. All right, this one says factor completely. If you look at it, it kind of looks like a problem that is halfway done being factored, except that x minus 6 is different than 6 minus x. It's very close, but not quite, right? So in order to make 6 minus x look like x minus 6, we can factor out a negative from it. Here, let me show you. I got my little thinking cloud up here to the right. If I were to take a negative out of 6 minus x, or if I were to factor out a negative 1, what I'd be left with in parentheses is negative 6 plus x. Well, if I just rewrite that, that becomes, in parentheses, positive x minus 6, which is what I have in the first set of parentheses for this example. So, if I'm going to factor a negative out of the second set of parentheses, it would look like this. 5x squared times x minus 6, that doesn't change. I'm pulling a negative out of the parentheses, which would make my positive 2 now a negative 2. And we already said if I factor out negative, that gives me x minus 6. So then I rewrite this as the product of two binomials, 5x squared minus 2 times x minus 6. 5.3 Part 2 homework is on mathexcelforschool.com, due Sunday at midnight.